Here's pre-calc. It's your lecture part 2 for 10.2.2, and we're going to do problem 10-120. So 10-120 says, Kevin is skateboarding when he hits a ramp to make a jump. The ramp makes an angle of 30 degrees with the flat ground, and Kevin leaves the ramp at a rate of 36 feet per second. And so they give us a little diagram. And it says, how far will Kevin travel in the horizontal distance after t seconds? So what I did is I made the diagram, and then I realized that I'm going to have a horizontal component and a vertical component, and I need to find out what they are. And so I made a right triangle, and then I have a 30, 60, 90 triangle now. And I know if this is the hypotenuse, 36, on a 30, 60, 90 triangle, the shorter of the legs is always half of the hypotenuse. So that's where I got the 18. And then the longer leg is always root 3 times the short leg. Or you could use a SOHCAHTOA on this. But basically, I got my horizontal and my vertical components here. And so to answer their question, how far will Kevin travel in the horizontal direction after t seconds? Well, after 1 second, if this is 36 feet per second, after 1 second, he would just go 18.3 feet. After 2 seconds, it would be 2 times 18.3 feet. After 3 seconds, it would be 3 times 18.3 feet. So it makes sense that it would be 18, oh, did I say 0.3? Root 3, 18 root 3 times t. Okay, that's the horizontal component. And then on letter B, it says, suppose Kevin is skateboarding in space and is not affected by gravity. How far will Kevin rise off the ramp after 1 second? How far will he have risen after t seconds? So after 1 second, I would say just 18. 2 seconds would be 18 times 2, which is 36. 3 seconds, right? It would be 18 times however many seconds, so 18 times t. So after 1 second, it would just be 18 feet. After t seconds, it would be 18 t feet. And then letter C says, since Kevin cannot skateboard in space, the influence of gravity must be accounted for. Gravity will cause an object to fall at a rate of negative 16 t squared feet per second. Adding the influence of gravity, how far will Kevin rise off the ramp after 1 second? How far will he have risen after t seconds? So they just want us to add the influence of gravity, and they just told us that the influence of gravity is negative 16 t squared feet per second. So I can just add the influence of gravity. So negative 16 t squared, but they're talking about just 1 second. So negative 16 times 1 squared, that's negative 16 plus 18. Remember, because 18t gives us our vertical component. So just it's going to be 2 feet, and then that's after 1 second. How far will he have risen after t seconds? Well, we know it's 18t, but we have to add the influence of gravity, so it'll be negative 16t squared plus 18t, if that makes any sense. This is the influence of gravity right here. And you're only going to use the influence of gravity on a vertical component, right? Not a horizontal component. And then letter D says, suppose Kevin leaves the ramp at a height of 3 feet. what is the vertical component of Kevin's motion? Well, so now it's going to be exactly the same, except for that he started 3 feet higher, like, like, you know, like 3 feet higher. So you can just add a 3 to it. So I wrote it out, y of t, negative 16t squared, that's the influence of gravity, plus 18t, that kind of has something to do with the shape of the ramp and some physical constraints that we have, and then 3, that's your initial height. And then letter E, what does letter E say? How long will Kevin remain in the air? So T is for time. So if I solved this for T, I would find out how long he remains in the air. So I tried to factor it. I went negative 16 times 3 is negative 48, and there's no two numbers it's not going to factor. So I went ahead and got the quadratic formula out. So there's A and B and C, and I plugged it all in. And I found out that he'll be in the air for 1.272 seconds. And then letter F says, how far will Kevin travel horizontally? Horizontally. So remember, when the seagull was dropping the shell, the vertical component isn't influenced by the horizontal component, if that makes any sense. So I'm just going to plug my time into the horizontal component, and if you can remember, the horizontal component was 18 root 3 times t. So I just went 18 root 3 times this time, and that's the horizontal component right there. And letter G just says, use a calculator to graph the set of parametric equations to model this situation. Confirm that your answers are correct. Be sure to adjust your window. So you could use Desmos. I have a picture of it. I don't think anybody would be surprised that it looked like an upside down parabola. Okay, and that's all I got for you today. Oh, here's a math notes box, though. So take a look at this math notes box, and I think our next section so this is projectile motion. So read that, and then our next 10.2.3, I think we're going to be talking more about that too.